Question 4. Give the potential differences V2 and V3. This is a simple parallel circuit. There are no resistors in the main part of the circuit. Remember, an ammeter is not a resistor. An ammeter has zero resistance. It just counts the current. It doesn't offer any resistance. So there's no resistor in the main part of the circuit. There are only resistors in the two branches. So it's a very simple circuit. Like this circuit in this example, it also doesn't have any resistors in the main part of the circuit. It just has two branches. And when we have a circuit like that, the voltage across the cell, which we can call Vn, is equal to the voltage across each of the branches. And that's because each group of charge goes through either this branch or that branch, not both branches. And as they travel along their circuit from positive to negative terminal, they have to lose all the voltage which the battery gave them on the path that they go around. And so those charges that go through the 2K resistor, they have to lose all the 9 volts which the battery gave them as they travel through their 2K resistor. And those that go through the 1K resistor, they have to lose all their voltage as they go through the 1K resistor. Another way of seeing this is that the voltage all along this good conductor is the same, because a good conductor doesn't remove any voltage from charges because it's so easy. The charges don't need to struggle through the good conductor, so they don't lose any of their energy. They don't lose any of their voltage as they move through the good conductor. So all these points are at the same voltage. You could also say they are at the same potential. And then the same for this good conductor, or these good conductors. All the good conductors here are connected to one another with no resistor in between, and so they are all at the same potential, or the same voltage, at 0 volts, because the voltage at the negative terminal of a battery has to be 0 volts. So for both of the resistors, the voltage at the start of the resistor is 9 volt, and at the end of the resistor is 0 volt. So if you put a voltmeter across the 2K resistor or across the 1K resistor, it will feel 9 volt on one end, 0 volt at the other end. 9 minus 0 equals 9 volt. It will read the same reading, 9 volt. Now in this circuit, of course, it's not a 9 volt cell, it's a 12 volt battery. But the principle is the same. The voltage all the way along these good wires, these good conductors, is 12 volts. Because those good conductors, and the ammeters as well, don't take out any voltage because they have no resistance. The charge doesn't need to struggle going through the ammeter. And then these points are all connected by good conductors to the negative terminal of the battery. So they are all at 0 volts. Because the negative terminal has to be at 0 volts. And there's no voltage change along a good conductor, along a wire. And so if we look at voltmeter 2, at one end it's feeling 12 volts, at the other end it's feeling 0 volt. Subtract 12 minus 0 equals 12 volt. It's going to read 12 volts. Voltmeter 3 also feels 12 volt at one end and 0 volt at the other. 12 minus 0 gives us a potential difference or voltage across X of 12 volts. So both V2 and V3 will read 12 volts.